I want to talk about proper measurement technique. We had you measure stuff in the Circle Lab. And we had everyone sort of do the best they could, and we demonstrated on camera a little bit about what that should look like. We're going to go over the actual rules that we need to follow going forward. And hopefully this will make sense having been through the one lab already. So this is going to be proper measurement technique. Let's say I want to measure something like the diameter of this quarter. And I'll just do this again in terms of lines. And your piece of lined paper might be a different size spacing between the lines. And so if you measured a quarter for the Circle Lab and you got a different number of lines than I'm going to hear, that's fine, because you just probably have a piece of paper with a different number of lines on it. So if I set this on here, the first thing I need to do is make sure that the 0 of my measuring device is right on the edge. And so I'm going to do the best I can to get the 0 line centered on the edge. And now if we look at this, we can see that it is closer to 4 lines than anything else. The problem is if we just wrote down 4 lines, and then we told someone else that we measured something was 4 lines long, they wouldn't know, did we mean exactly 4 lines? That's obviously not what's going on. Or did they just mean it was, or did we just mean it was closer to 4 than anything else? But that could be a pretty big range. It could be anything from here to here. Anything from about 3.5 to 4.5 is closer to 4 than anything else. And if we're trying to communicate the size of this quarter as precisely as possible, we need to do better than just saying 4. And so what I did when I was making measurements, and what hopefully you did, was try to estimate where exactly it is in between. So then the question is, how precisely do we need to estimate? And that isn't something that I explained when we did the original Circle Lab. So do we just go to the nearest half? Do we go to the nearest quarter? Do we go to a tenth? Do we go to a hundredth? What's realistic? It turns out, just sort of the way the human brain works, we should be able to realistically subdivide any spacing into tenths. So we should always be able to go 1 decimal place beyond the smallest mark. And so I would not want to just call this 4.5 or 4 3/4 or something. I should be able to get all the way down to tenths. And so this, to me, I'll actually not say what I think it is yet. I would like you to look at that and decide, what do you think it is? So it's not quite 4, so it's 3 point something. 3 point what? So go ahead and think about what you think it is. I think, looking at that, that is about, I would say, 3.6, I think, is closer than anything else. But some of you might disagree. Some of you might have thought 3.7. Some of you might have thought 3.5, depending on where exactly you think it is. The thing is, even if we don't completely agree, is it 3.6 lines? Is it 3.7 lines? Is it 3.5 lines? Any one of those better communicates the size of the quarter than just saying 4 lines. Because no matter which, if we've narrowed it down even just to that range, even though we don't know the exact size of the quarter, if you were going to try to tell someone exactly how big the quarter is, if they knew it was somewhere in that range, somewhere between 3.5 and 3.7 lines, that gives them a really good idea of what's going on. And so whenever we make measurements, we want to do the best we can, which is going to involve going down to an estimate. And we're not always going to agree on what that last decimal is, but by including that last decimal that has an estimate, it's going to give us more information than just going to the nearest whole marking that we can know precisely and for sure. We can communicate better information by including that estimate. So, a properly made significant measurement . Significant measurement should sound kind of familiar. Those of you who've taken chemistry talked about significant figures, which are the mathematical operations that help us keep track of where this estimate that we just talked about is in any properly made significant measurement. So a properly made significant measurement is one in which the second to last digit is known precisely, usually because whatever measuring device you're using has a bunch of markings and you can tell, what the last marking it's at is. And then we want to go one step beyond that to give a little bit more information. So the second to last digit is known precisely, and the very last digit is an estimate. And our general rule is that we should estimate to one decimal place past the smallest marking on our measuring device. Whenever possible. So to go one decimal place, you have to subdivide it into tenths and go one place beyond that smallest mark. And so, for example, we said that the quarter was, what did we say, 3.6 lines wide is a quarter. The 3, we know that one for sure. The 6 is the estimate. And because it is an estimate, it could be off by a little bit. But we should be able to get pretty close. You should be able to get within the nearest tenth. So when we say it's an estimate, it should be within one of the right answer. So could be 3.5 or 3.7. But by saying 3.6, what we are communicating as scientists is that, to the best of my knowledge, I think it's 3.6. This might be off by a little bit. It might be 3.5. It might be 3.7, but it's in that range. And that gives me much more precise information than just saying it's 4 lines wide, which could be anywhere from 3.5 to 4.5. By going to this place where we are estimating and don't know for sure what this last digit is supposed to be, we actually communicate the best information possible. I said on here that we want to go to the smallest marking on our measuring device whenever possible. The reason I phrased it like that is that every so often you might be measuring something that is just really, really hard to tell where the edges are, or that might not have well-defined edges. So if I'm measuring like a Post-it note, for example, we should be able to measure that just fine. But if instead I have like a torn piece of paper, it looks, like this. It's got all sorts of different shapes here. Depending on where I measure and where the fuzzes are, I don't know for sure exactly what this is. And so it wouldn't make sense to go to the nearest tenth of a line on this. Here, I can really probably only actually go to the nearest line. So the smallest digit, if I only have one digit, is the one that's an estimate. Because like here it looks like it's about 7. You know, here it gets closer to 8. And so, you know, I'm going to write down the best thing I can. Yeah, it looks like it goes from about 7 to 8. It's 8 more of the time. It's closer to 8 more of the time. And so I would estimate that as being 8 lines wide. When I say 8, what that's communicating is it could be somewhere between 7 and 9. And so just as a quick shorthand, that's a good way to give the range. Closest to 8 could be anywhere between 7 and 9, which is true for this. But most of the things that we measure, you're going to be able to do this thing, where it's going to have a pretty well-defined edge and you can actually go 1 decimal place past the smallest marking. And that is true even when we're not using lined paper. When we come back into actual school and are using a ruler, we've got centimeters on here and millimeters are marked, so tenths of a centimeter. But when you're measuring something with this, you can actually tell where it is in between the little millimeter, in between the tenths of a centimeter lines. And so since we have marks every tenth of a centimeter, you should actually be able to estimate to the nearest hundredth of a centimeter with one of these. If we're using a protractor to measure an angle, this particular one is measured to the nearest degree, so you should be able to estimate to the nearest tenth of a degree inside of there. I've got a force measuring device. We'll talk about force later, but force is measured in newtons, so this is just a little scale that tells me how hard something's being pulled. And it is marked in newtons, and it's got a line. So if this is 0.5 and that's 1, we've got lines every 0.1 newtons. And so I should be able to estimate when this is making a measurement where exactly it is in between the tenths, and so I should be able to go to the nearest hundredth of a newton with a device like this. So as long as everything is stable and it has well-defined edges, we should always be able to estimate to the nearest tenth of our smallest marking. The only other thing to talk about is what do you do if it looks like it is right on the mark. So if I was measuring something that looked like it really was like an exact increment, how do I describe that? So this Post-it, for example, looks like it's pretty much exactly 6 lines wide. The thing is, it might not be exactly 6. It might be 5.99. It might be 6.01. I can't really tell for sure, but it's pretty close to 6. I wouldn't want to just say 6 because if I just say 6, someone listening to that thinks, okay, well, it's plus or minus 1 on that last digit, so maybe it's somewhere between 5 and 7. We know a lot more precisely than that. We know it really is really close to 6. And so in this case, I would want to still add that last decimal on. I would say it is 6.0. And so it could be plus or minus 1 on that last digit, so it could be 5.99, it could be 6.01. But I want to make sure I'm always adding that last estimated decimal place, even if it's a 0. So in this case, my estimate is that it's right on the line, 6.0.